Hello, this time I want to recognize this table and then cut along those lines to get every single cell out of there. But I could do that quite easily with a computer program and define the lines and then cut along them and crop out all of the sub-images. But imagine you have tens of thousands of these sheets and you want to do it for every single one of them. Well, that's where you want to write an algorithm that does that for you. And that's especially useful if you want to extract that information from these sub-images, from these cells. Because you can then, in a further process, use OCR on these cells and extract the information that's in there. So if you've got data in the form of such sheets, you can then read it out with a program and, let's say, export it into Excel. So that's really helpful if you want to do that, because it's just a monotonous task that no one wants to do, and it's just very time consuming. So how did I write a program that does that? I'm going to tell you that in the following minutes. So you start with just a table in a picture, in a scan, for example. That's the cleanest way you can do it. You can make a picture with your phone, but the best way to do it really is put it into a scanner. So the first thing I want to do is kind of convert this image to just the edges. I just care about the information here about these edges. So I use something that's called a canny filter, and that's just doing what I just did, what I just said it would do. It's just gonna get me all of the edges. If there's a big color gradient, a big gradient in saturation, like if there is some noise here that's like arranged like this, it's also going to recognize that. So now we have a little bit a cleaner image of that table than before, and what I'm gonna do after that is blur all of these lines or all of those edges a little bit, and then cut it off at some threshold. What I mean by that is, if you have a pixel here or a whole line here, let's say it's 1 pixel wide, we want to blur it. We blur it along here. Then this part is a little bit gray. You have to imagine that a little bit gray and getting less gray up until white out here. It gets less gray, and at some point, at some gray value, you want to cut it off to make it wider. Because first we had that line, we blurred it, and then we took all of the gray values until some point, and make it full black again. So and the little bit of gray, it just gets white in the end. It's not going to get black. So the result of that is just thicker lines in general. Now we have thicker lines, and the algorithm is going to perform better on that. Thicken. I'm going to write thicken here. And next thing is a line detection algorithm. This is the reason we did the previous steps, to find lines in this table. It's also going to detect some lines if you have just a 1 here all the time. It might detect that as a line, so you've got to be careful with that. So we've got thicker lines here, so our line detection algorithm might also find a couple of lines here. So it might look something like this, somewhat like this. Okay, and that won't help us a lot, because we want to find the cuts here where they cut each other, the intersections. So first, what we want to do is extend all of those lines. So what we then have is something that looks similar to this table in there. It's our table. And we have the lines like this. So there's a lot of lines per actual line in the table. So I think you've caught my drift. Problem with that is now it's not unique. So all of these intersections are not unique. So what I did is I'm going to omit the image border now. This is just my table now. What I did was split vertical and horizontal lines. So I checked which ones are like similar to this vector, which lines are similar to this vector, and which lines are similar to that vector, to the 0, 1 and the 1, 0 vector, so to say. And then I got two groups, like vertical and horizontal, and I projected the vertical lines onto that edge of okay, I'm gonna draw the image borders out there once again. So this is the image border, and I calculated the intersection with the upper upper edge of the image, and I got some cuts here, some intersections here too, and here too, and then I used a clustering algorithm on that. So I'm gonna say intersect, and I'm going to cluster all of these intersections, and I also did that here, of course. So all of these lines got me some intersections here, some here, some here, some of them here, and then I clustered them. So I know these are in a cluster, these, and all of these here too, in 3 different clusters, and that helps me a lot, because then I can just see which ones are in one cluster and calculate something like a mean of that. So first we cluster them, and then we calculate a mean of all of those lines. So if I got we will call that unify. I'll unify all of those lines in one cluster. Let's say this is our first vertical cluster. We have these lines. So I'm going to calculate the mean here, of the cuts here, and also of the intersections here, and I'm going to connect that. I hope you can see what I did there, and I've got a new line, a unified line. I'm going to do that for all of the clusters, and I'll end up with something way cleaner, something that looks like this. So this will be the image border. This is the border of the table. Actually, no, not gonna draw the table here. Just going to draw all of the lines. Okay, you might have seen me use a different number of columns and rows here and there, but that's just to simplify everything and to make it cleaner. So I've got this, and in further steps I can find the intersections of those unified lines, and then I can crop that out. Well, it might happen that you'll get some cells like this. So if you're if these lines are not perfectly straight, you can get something like that. You can then use some code that unshares those shared cells to get it back to this form. So one more thing I want to say is that here in this step where you cluster these, you'll have it'll help you a lot if you use the number of clusters you want to have. So that is the number of columns you have here plus 1. If you give the algorithm that number, it'll find that many clusters, and it's just going to be more accurate. Same, of course, for the rows, for the row clusters. Okay, so then you'll get all of the cells if you crop them out, and whatever data is in there, you can extract that with optical character recognition. If that works well, that's good. If it doesn't, and you only get like 80%, it's still a big help, because then you can just check if those values are right, and you can check with the images and don't have to type in everything and just need to correct some of the mistakes, or all of the mistakes, of course. So I hope this is helpful for you, and see you next time.